Good morning, everybody. Day 3. Hope you're having a great convention. My name is Barbara Carlson, and I have a pleasure of introducing this morning's session. We're going to talk about the next generation exciting thing in AI, personal assistance. So this fireside chat will be led by Kanjun Q. Kanjun is the founder and CEO of Imbue. Imbue was founded in April 2021, just finished Series B with over $320 million and is valued at $1 billion. And she's working on next generation of personal assistants that can code and reason. She'll be talking with Brian Catanzaro. Brian is our VP of Applied Deep Learning. Brian's been with NVIDIA since 2008, so he's participated in about everything from gaming to chip design. So looking very much forward to an exciting conversation this morning. Thank you.
Well, good morning, everyone. It's a bright and early Wednesday. I hope GTC has been good for you. Yeah.
Kudos on coming at 9 a.m.
I know, right?
It's like
is the coffee good here at GTC? I haven't had any yet.
No.
We better put that on the list. Accelerated coffee.
That's right.
Yeah. Fantastic. Well, we're really excited to join you today to talk about the future of AI agents and how we think that agents are going to change the way that AI is built and deployed and used, and hopefully solving problems for industries around the world. So that's kind of the theme of our discussion today, and I'm really excited to be talking about this with Kanjun because she's leading this amazing startup, Imbue, that is building agents to try to help with this. So that's what we're going to be focused on today. But maybe just to get started, because some people may not have heard of Imbue yet. Tell us about the way that you're thinking about agents and the problems that you'd like to solve.
Yeah. So I think when people talk about agents, the image that we have in our head is this like personal assistant you like delegate tasks to. It'll go do stuff by itself in the background. And it'll be like something like Jarvis. You can just tell it to do anything it wants, and it'll magically do that thing. And many enterprises, as we talked about, try to implement something like this, and it doesn't work. And hopefully, I encourage you all to try some agent products out there.
Can I just give an example?
Yes, please give an example.
The other day, I was driving to work, and my schedule is a complete disaster. I usually have 5 meetings scheduled at every hour. I don't have an actual person that is sorting through my schedule. That's my job. So I was driving, and I'm not supposed to be looking at my calendar. So I asked my phone, hey, what building should I drive to? Yeah, it was absolutely impossible.
Not a good idea.
There was no way for my phone to answer that question. I feel like it should have. I feel like with the way that AI has been developing,
it should know. You should be good at this kind of thing.
Question, but there's a lot of ambiguity in this question, right? Like one ambiguity is that like it needs to know that I'm talking about going to work. It needs to know that my work calendar, it needs to have access to my work calendar. It needs to see that I have 5 different meetings. They're all in different buildings. And then it needs to ask me, which meeting are you actually going to?
Right.
And so there needs to be some sort of like problem solving that's really woven into the fabric of my life that I get to sort of work with. And the way that I need to do that might be different than other people, right?
Totally. Yeah, and I think this actually goes to this idea that this like magical thing that magically knows everything about you and like will magically do the right thing is not necessarily the right paradigm. And actually, the way we think about agents, and this is actually, we started out thinking about agents as assistants, and we built a bunch of them for ourselves. We built like a recruiting agent and one that like synthesized articles, long articles, and like a bunch of other ones. And what we realized is no one likes to delegate stuff. Like actually delegation as a paradigm is really difficult. Like when I'm delegating something even to a human, I have to think a lot about, okay, how exactly do I package this up so that the person will do the right thing? And like, how do I get it to a point where, when do I check in? And 50% of the time, I don't get what I expected
You don't
back.
get what you want. You know, it's funny when a bad thing happens, it's a common question that people ask, what can I do to help? But that actually causes work for the person.
That's right. It puts more work on me.
It causes work because then you have to think, what's the intersection of things I need and things that's possible for you to do?
Exactly.
That's also not too crazy to ask for.
And then how do I scope it in my head up front so that you can do it properly? So this is like
delegation is hard.
Delegation is hard. Delegation as a paradigm for agents, not the most powerful paradigm. Maybe there will be some agents that are very limited in scope that we can delegate to. Instead, at Imbue, the way we think about what agents are is, if you think about this like magical Jarvis future, where you can tell your computer to do anything you want, then you've got like you telling your computer to do stuff, and the agent is the middle layer. You're telling the agent, okay, I want to do X, and it has to talk to you. We call that reasoning. And it has to talk to your computer, and we call that code. It does that by writing code. And so a way to think about what agents are is they are basically taking what you're interested in and writing code to talk to your computer to get your computer to do what it wants. And so kind of taking that line of reasoning down a little bit, a way to think about what an agent is it's basically an abstraction on top of programming languages today that allow me to write software programs in natural language and in a way that's interactive and not just kind of like one-sided. I tell it what to do and it'll write the whole thing and then I'm done. It's this kind of like back and forth. And so we think about, so we train foundation models, we optimize them for reasoning and code to support this whole process. And I actually think like the abstractions that we choose are really important on top of programming languages. And whether we choose the right ones or not, that's going to like make it much more or less usable. And those are all things that we think a lot about.
Wow. So in this vision, the way that humans interact with computers through agents is really about making everybody a programmer.
Yeah, without thinking of ourselves
thinking of themselves
as programmers.
Yeah. You know, what does a world look like with 8 billion programmers on it?
Yeah, it's really interesting because, you know, I think a lot of people, we talked about this briefly, a lot of people feel very disempowered today, especially when it comes to technology. We're like mad at big tech. I get mad at Facebook. And we're disempowered because we literally have no power. Like, I can't change the technology around me. I don't have the power to do that. And I think there's a world in which when everyone is able to change our computing environment, like computing is such a fundamental thing. It's about information. It's about processing and encoding and transforming information. And that's like the fundamental to human existence.
I think it's also about the search for meaning. You know, when I sit down to write code, often I have this brilliant idea and I'm like so excited to like write it down. And I sit down and I'm like, import.
Yes.
What am I going to import? And then I'm like, I have to think through it. It's like, well, I could import this thing or this thing or this thing. They're all different. And the reason I'm going to make a choice is because of the thing I'm trying to do. The problem is that like it's actually not just a mechanical process of like transcribing an idea. It's actually I don't understand my own idea very well.
I don't understand what I want yet.
I don't understand what I want, and the act of programming is an exploration, an elaboration. It's actually taking an ill-shapen, malformed idea and then turning it into something that's so concrete that it could be executed.
Totally. Actually, one thing that we've realized working on this is the structure of code and the process of writing a program basically maps, it's like isomorphic to the structure of doing tasks and accomplishing goals in the world. If the same thing happens when I'm trying to do anything, I don't know exactly what I want in the beginning, and through creating the thing or through trying to do it, I learn more and I figure out more about what I want, and I break things down in a very similar way, and I encode some processes very similar to code. So to your question of like, what does the world look like when we have 8 billion software engineers? That's like a totally different world where basically, a lot of technology modes will be disrupted today. But something I imagine is also something that's kind of like a creator economy for software, where today we have Substack for writers, and writers can write very niche things, and there's this idea of like 1,000 true fans. And when you have your 1,000 true fans, then you can make a living. They each pay $10 or $20 a month. And today, I think like software is way underwritten. We would probably write like 1,000,000 times as much software if we could, but it's really expensive. And if software, one of the ways we think about what we're doing is we're making writing software zero marginal cost. If software
Zero,
is
that's a small number.
zero is very small. Eventually it'll be zero. But if software were zero marginal cost, then it would be much easier to make all of this niche software for stuff that, I want like a research IDE where I can ingest papers and like go through them and connect ideas between different papers. But you might want a slightly different research IDE. And right now, these products are not worth building because they're too expensive to build for the value that people are willing to pay for them. But if the cost goes way down, then we get something where all of these niche products are worth building. And it's actually very similar to what's already happened with manufacturing and the Industrial Revolution, where it used to be really expensive. Someone told me a story that the guy who invented the steam engine took him like 4 years to build a piston that seals. And so like that's really important for a steam engine. And today I can buy that off Amazon, it's like 50 cents. And because our material environment has become so cheap to produce, now we can create these amazing things. And I think that's also true of our digital environment. We're just at the very, very, very beginning. So that's what agents are.
Yeah, I love that vision. I love the vision of empowering everyone around the world to solve problems with computing.
Yeah.
And because I do think it's true that everybody exists in a slightly different context and has different goals and problems to solve, and giving people the power to do that, actually giving me, even with a lot of training in software engineering, I still don't write as much software as I'd like because it's a lot of work. It's hard.
It totally is a lot of work. You could write 50x as much software.
I would love to do that.
1,000,000 times as much software.
Yeah.
If we succeed.
I would totally love to do that. Awesome.
You actually had a point about. Actually, let's keep going. Yeah.
Okay. Well, I wanted to talk a little bit about the gaps between the dream of generative AI and all the promise of the technology that we see around us, but then the real world usage of this technology isn't nearly as broadly deployed as I would like it to be. And so I was wondering what you think about that.
Yeah, I think that's totally true. Like what we observe in enterprises is they try to use Gen AI, and there's a really interesting anecdote from the Snorkel CEO where he's like helping enterprises train their own models using their own data, and they get to like 93% accuracy. And I'm like, is that enough? He's like, no. For a lot of these use cases, you need it to be like perfectly good. So I know that you guys are also working on bridging the gaps. How do you think about it?
Yeah. I think that question of like, is it good, actually makes me think about the agents that we were talking about just a second before, because I think that that's one of the fundamental questions in using generative AI, and it depends so much on the context and the way that it's being used in an application, the guardrails that are around it, and also the way that the models are being used against like databases and other sources of validated facts. But the process of like how do all these things get woven together seems right now so bespoke, and I do think that's one of the reasons why it's so hard to deploy generative AI right now. And so I'm thinking, based on what we were just talking about, how could agents help us?
100%.
bridge
Yeah.
that?
When we started working on writing software, we realized like, writing agents, we realized like, this is like 99.9% writing software and 0.1% figuring out what to write.
Yeah.
So yeah, I think making it much easier for people to encode what they're trying to do in software and use them. I kind of think of like software encodes hard logic, it encodes processes for information. And knowledge work is just about processes for information. Knowledge work is like transformation of information encoded in people. And the reason we as people can encode it is because we can deal with a lot of ambiguity. So not everything has to be hard-coded. And what AI lets us do is, okay, it lets machines or software deal with this kind of ambiguity. We still want to encode the processes, so that's still software. And there's this idea of like LLM core versus code core. LLM core is this idea that you make a big LLM or multimodal model, you pass in your input, and it magically gives you the answer. And like, you're writing an essay, it'll magically give you the essay, or magically it'll talk to you to figure out the right essay.
Yeah.
And I don't know if this is realistic. I think like we encode a lot of processes in our habits. We also encode processes for transforming information in our organization processes. So.
Yeah, and I love the sort of empowerment and diversity that could come from that. One of the challenges, of using language models to do knowledge work is that they tend to be fairly smoothed over, right? Which they need to be in order to be aligned and in order to be safe and so forth. But because of that, there's this sameness to it, right? Like, and people will notice, like,
it's generic.
Yeah, it's generic. It's not actually. So there's a lot of like, it's like kind of amazing that a model can say this thing that's like interesting, but it's also like way less interesting than it should be because of this gloss that's kind of laid over it. And so what does a future look like where people are expressing themselves using language models, right? I think the sort of new perspectives, new ideas, new ways of thinking that will come from that are pretty profound. Because I really do believe that pretty much, I mean, all 8 billion of us on the planet have something to teach each other. It's really difficult to do that for a lot of reasons. But what if we were able to sort of each of us individuate and maximally explore the things that we're interested in?
Yeah, I agree. Like, we don't even realize it because we live in this world, but like. Our lives are full of so much friction. Like, we have to micromanage our computers and like make it do everything we want. Like, I sit down to build an idea and import is the first thing I write.
Yeah.
Like, that's way too low a level of abstraction to be working at. And a way that a future could be is like every single person's vision can come to life. This like barrier between idea and execution can be much smaller.
Yeah.
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 To your point about language models being generic, though, I think there's some really interesting stuff that we see internally where if you break down the problem we break down the problem into thinking about how do we make code abstractions, how do we make it easier to write software in natural language. So if you break down the problem, then you can actually call the language model or whatever model you want in much more specific situations, and it performs a lot better. And it tends to be less generic because it's not trained on, maybe it's trained on the entire internet, but it's like then fine-tuned and then RL star F'd for this particular situation.
Yeah.
Yeah.
Yeah. Right. So how do we get to a future where everybody's RL star F'ing their own model, so that they can learn how to do their own thing?
Totally. Or I think actually that a lot of these tasks are much more general than we think. Like, I don't think you're going to have to RL star F your model after it like knows how to program for me. Yeah.
Yeah.
It's like all of the programming abstractions are actually pretty similar across different use cases. For example, like a function, we work a lot on generating and testing functions, and that's like a basic building block for programs. Once you can generate and evaluate whether a function's correct, now okay, you can automatically generate infinite functions and figure out if it's if it does the behavior that you want.
Yeah, if we know what we want it to do.
If we know what we want it to do.
There's the search. Yeah.
But actually, what's interesting about this is like, okay, I'm using our system, and what it allows me to do is work at a higher level. So instead of you starting with import, you can start with, okay, I want, one thing I wanted yesterday was to like go through everyone I know and find all of the people in my network that I can reach out to for user interviews who are BizOps people. It's like, okay, I'm like manually going through LinkedIn and my email to do this and use clay.earth, which is a product that kind of does this, but it's not perfect. And so if I wanted my agent to do this, then the first step it would say is like, okay, where do you want to go? Like, where do you want to look for these people? And I can be like, I want to look for people in my email, because on LinkedIn it's not reasonable. And then the next step, it can be like, okay, well, I've gotten you some outputs, like a list of people from your email. Do these look right? And now I can just work at this input-output level instead of being so focused on the exact implementation details.
Yeah.
And so it lets me work at that higher level, lets you work at that higher level.
Yeah. Yeah, that makes sense. So this vision that Imbue has is a really broad vision. It's so much bigger than a code assistant, right? There's a lot of code assistants, a lot of code models out there, but I think what you're talking about is so much more than that, right? It's really about changing the way that we think about problem solving, you know. And what convinced you that now was the right time to build a company to do that?
Yeah. I've always been interested. My co-founder and I, this is our third company, and we'd always been interested in general agents, systems that could make computers do the stuff. You know, we've always felt like we haven't gotten the full power of computing. In the 70s, people were really excited, and now we're 50 years later, and we're still clicking around. And in 2018, so the last company we started was actually a very specific AI agent company called Sorceress. It was applied to recruiting. Started in 2016. And we had a few million in revenue and did YC and raised a Series A. And then in 2018, some of our housemates started building GPT-3. Actually, Tom Brown and Ben Mann, the first authors. And we started to see like, oh, wow, scaling works. That's crazy. Maybe it doesn't work across all use cases. And all modalities, but we thought if it works across all modalities, if self-supervised learning, where you can just give it any data and you don't have to label it, if that can work across not just language, not just text, but also images and video, then maybe we have some fundamental learning mechanism here. And in late 2019, that started to happen with SimClear. I think the first kind of like fully self-supervised image classification beating supervised image classification. So at that time, we were like, okay, now it's the time to work on general agents. And we actually started, when we first started, we were very interested in decision-making in reinforcement learning. We thought decision-making was the hard part of the problem. But it turns out, I don't think decision-making is the hard part of the problem. Once you have all of the right context, once you are able to robustly do things, then the decision is relatively straightforward. Like lots of plans work, but the execution needs to be quite precise.
I think we tend to underestimate the things that we do naturally and overestimate the things that require like cranking.
Totally.
You know, and it's like, one of the things that humans are just so amazing at is dealing with ambiguity and this sort of like implicit exploration of what we want. It's happening all the time. We have the subconscious that's working and we don't even know that it's happening.
Yeah.
But it's actually doing a lot.
It's doing a lot. Yeah, a way that I think about what we're doing is like reasoning is actually an easy problem. What we want to do is not have the model reason about everything and magically come to the answer, but rather have the model pull reasoning out of humans.
Right.
Because we're the ones who are in the environment, getting all these inputs. We have some intuition for what we want. What we want is for our systems to pull that intuition out of us.
Yeah, right. Yeah, for sure.
Yeah.
Well, let's talk about the interface for how people are going to work with agents. I think, a lot of the systems today are built around text, whether that's like typing into an IDE or typing into a chatbot. How's that going to scale? Like, how are people going to work with these things?
I'm going to turn the question back on you first, because you have interesting, I would say, crazy thoughts here, which are
crazy
really
thoughts.
Cool. Crazy
I don't
thoughts.
know. Crazy thoughts.
I can answer briefly.
Why don't you go first?
Okay.
Yeah.
So yeah, we think about interface a lot, and the reason is because really, like, Imbue has two main strategic focuses. One is capabilities, which is like, can we actually generate a function effectively? Can we actually create these like building blocks for code? And two is essentially like, how intuitive is it? And the way we think about it is like, there's kind of, the more intuitive you make the product, the more people can use it. So right now, if it generates code, but it's not very good, I have to go in and edit the code and figure out what's broken. That means I have to be a software engineer in order to work with the system and to make software. But if we can make it so that, okay, I can generate functions effectively, then I can work at least the input-output level. I can like architect a whole system and be like, these are the inputs and outputs I want, and here's how we connect the data together and how it flows. Then I don't have to be a software engineer. I can be a business analyst and still be able to make that system. But I still have to think in this systems way. So it's not accessible to everyone.
Yeah.
Certainly not everyone's going to do that. Then you make it more intuitive where the agent knows how to architect its own systems. Then, and like it doesn't get into these crazy messes and it can make something future-proof. Then I can be more of a regular person. Maybe I can be a general knowledge worker and I can get it to do all of these business processes that I want it to do. And then eventually one day, if it's actually good at collecting context from my environment and knowing what I want, maybe then I can have like a magical general thing that regular, like normal people can use.
Yeah.
Yeah.
Yeah. Yeah, I agree. So I've always been interested by this question of what is interesting to other people, because I think that that kind of points the way to how we're going to want to interact. And I think text interfaces, most of us don't actually want to read or write very much. It feels like work. It feels like work. And so when I'm thinking about how are people going to want to solve problems with agents, I'm thinking an interface that's interesting, like fundamentally interesting and engaging to work with, is going to be a lot more accessible. I do think that one of the barriers to entry for programming, for example, is that the IDE feels forbidding, right?
Yeah.
And so
it's complicated.
So in this vision of like 8 billion programmers working with agents, what does that interface look like? I think if we look at what people actually enjoy interacting with today, I think the most successful thing is games. Actually, the way that people interact with virtual worlds is very interesting. In fact, some of us have to regulate how much our children interact with those experiences because they would prefer to just never leave, And so I'm thinking about that, like the engagement, things that feel natural, things that feel interesting. Like if we can make it feel interesting to solve problems with an agent, what kind of interface is that going to have? And I do think that virtual worlds are going to be a big part of that. NVIDIA has been working on this thing called Omniverse for a long, long time. Starting with our roots in graphics and sort of the idea that it's really important to be able to simulate the world and to interact with entities in virtual worlds. And so I'm thinking about how these things come together. And I have come to the belief that AI needs virtual worlds. I think the other side of like virtual worlds need AI, that's kind of converse of that, seems a little bit more obvious because like building virtual worlds is really hard right now, and it's it's actually the same problem, right? Like we're just kind of going around in this loop of like it's really hard to build software, so we don't have enough of it, so then we don't solve the problems in the right way.
Yep.
So I'm thinking about so it's like I think pretty clear that like AI is going to help build virtual worlds. I think maybe the more controversial part is that I think virtual worlds are going to be necessary for humans to interact with AI.
I think this is actually really interesting. Like in some future operating systems will be dime a dozen. You can just pick the one you want. So like a virtual world as operating system is actually pretty interesting for many people, like a whole class of people. How do you deal with knowledge work in virtual worlds? Like, is it, because text is efficient in a lot of ways. It's like a compression. You can read a lot of it fast. It's faster than speech. You can see all of it up front. But virtual worlds maybe not a good place to have that much text.
Yeah, I mean, I don't think text is going away. I'm thinking more about the 7 billion people on the planet who aren't doing that right
That's
now.
fair.
Are they ever going? So is there a future where AI is so useful that the 7 billion people that currently are not spending time reading and writing decide, actually, this is the best way for me to spend my time is reading and writing? And I'm questioning that. I just don't think that that's maybe as interesting. Like certainly, like when I look at my friends and family, I have a lot of friends and family that would much rather do something else other than read and write. But in this future where like everyone's a programmer, everyone's engaging with agents, how are they going to do that? So that's kind of the way that I'm approaching
It's
it.
true. I totally agree with that. Actually, maybe a lot of the knowledge work we're doing today, the reading and the writing AI systems will be pretty good at, and so we can like focus our time on discovering new things or creating experiences for each other.
Yeah,
And
exactly.
these environments are good.
Exactly. I have this belief that AI that solves really important problems behind the scenes is actually it's very valuable in the sense that it's practical, but it's not very valuable in the sense of like how's it going to drive our economy and our culture because it feels like infrastructure.
Yeah.
I always make the joke that one of the most important companies in artificial intelligence is Pacific Gas and Electric. Here in California, because there's definitely no AI that's happening without Pacific Gas and Electric, and they are doing actually really hard things.
It's
Like,
really
do you know how difficult it is to provide energy to millions of people or billions of people around the world? Like,
Totally.
it's super challenging work. In fact, the work of providing energy is likely to be one of the last things that gets automated, I think, because it's actually just really hard. And so now the thing is though about PG&E, although I do think that there's a lot of foundations that are just absolutely critical to the way that we live today. Because we're not thinking about them, because we have delegated that, we've kind of abstracted that away, it just doesn't become the focus of our culture. Now, it used to be actually the case that electrification was the focus of the culture, like 130 years ago or something like that was.
100 years ago, yeah.
100 years ago, like that was a thing where like people were just obsessed about it. Like if only we could have electricity, then we could like have a well that brought up water for our house and we wouldn't have to walk so far. And like so there was this time when like getting electricity was like a thing that like really occupied the mind
Totally.
of our society. And then once we solved that problem, it became infrastructure. And
think another-
nowadays people don't think about it.
Totally, I agree. Like foundation model companies today will be boring in the future.
Yeah.
Yeah.
Right.
And also another interesting thing about the electricity example is electricity is now regulated as a public good because everyone uses it. And I think actually like there's something about foundation models that probably will or should be regulated as a public good, where it's like providing this service to society as an infrastructure layer. And then we can build interesting stuff on top of it.
It's an interesting idea. Right now, I don't trust our legislature to understand foundation models
we'll
well
see.
enough to regulate them, but maybe one day they'll become more sophisticated there. Yeah, so I think this interface question is really interesting, in this vision of like agents building a bridge to between the capabilities of computing and artificial intelligence and the people that actually need to solve problems, and then how do they go about accessing that? I think it's a really important question.
Yeah. I feel like there's going to be like a Cambrian explosion. This is not a great analogy. Cambrian explosion of interfaces in the future where like, people can build all sorts of operating systems, all sorts of interfaces. Some of them will be virtual worlds. Some of them will be hardware that projects onto my, I don't know, shirt. Some of them will be like speech. And when it's easy to build software, we can connect them all together much more easily.
Yeah.
And I think importantly here, like we're relying on the humans to make these decisions about how to connect them together. And I think this is like a very different vision than the like classic AGI. AGI will know all the answers, it will solve all the problems, it will make all the decisions, and we're the ones who, we're being told what to do, and it'll know what to do. And once it tells us what to do, we'll like magically end up with a nuclear reactor. Like that's a very disempowering future.
It's a human uncentered, like the humans are
Exactly.
peripheral.
The humans are peripheral. The machine is in the center, and I think this is like totally wrong.
Yeah.
And also it's not a world that we want, and we can choose what kind of future we want to build. But I think this is the dominant narrative when machines are at the center.
Yeah, it's interesting. Humans, like we just generally are afraid of being displaced. I think that's just it's like a core fear. It probably has to do with tens of thousands of years of trauma.
Evolution.
Yeah, exactly. And so this is like deeply embedded this fear that like we're going to be displaced. I think the human-centered AI that you're talking about building is not displacing; it's augmenting.
Exactly.
It's empowering. It's like a thing that brings out the brilliance of all the people on the planet in their different ways.
Exactly.
You know?
Yeah, we think of like, the classic AGI vision, this very disempowering vision, thinks of machines as gods. And we want to think of machines as tools. Like machines have always been tools. They should continue to be tools. We can choose what kinds of tools we make. We can choose not to make tools that are conscious, things like
Yeah.
that. So yeah, I agree with you.
Yeah. Great. Well, what
Should we open up?
we've got just a few more minutes. I guess where do we want to take this? Where does Imbue want to take this? What kinds of exciting things are you envisioning that you're going to be providing?
I think we talked about a lot of it, but there's kind of these stages of we want to make it much easier for relatively technical people to make software, and then much easier for non-technical people to make software, and then eventually much easier for everyone to make software. And we won't be thinking about what we're doing as making software. And kind of more and more of the reasoning and understanding the world will be encoded into the agent. And where we land is kind of a world where anyone can really take a vision that they have, that they want to create, my research ID, your virtual world, and it's fairly straightforward to create. Some things will be much harder than others. Maybe virtual worlds are still hard. You still have to build all the apps from scratch. But that's a world in which basically all of us can shape our digital environments the way we have the power to shape our physical environments. Right now, I can buy a plant off Amazon. I can manufacture some things in my house. My house will look different than your house. But today, all of our houses look the same, except maybe our tables are different colors or something.
Well, there's a little box that I can click on my Facebook feed that says "show more" like this, or
Right.
"show less" like
Yes,
this.
yes, we've got different trinkets in our drawers.
Right. Yeah.
But yes, one day, I think of it as really being able to totally control our information environments, and I think we're actually pretty early in the study of information, and in 100 years we'll really understand information is very core to life, and all life, not just human life. And people, I think, once we have more control over our information environments, will feel a lot more empowered to do the things that we want to do in the world.
Yeah. Yeah. I hope we can figure out how to use that in ways that connect us as well. One of the challenges, I think, of individualized information is disconnection. And sometimes people will ask me, Brian, what do you think about virtual worlds where everybody gets to play their own game? You just talk to the computer and you're like, hey, I want to play a game that's kind of like Call of Duty, but it's set on Mars or whatever. And then the computer thinks about a plot line and characters and populates it and makes missions to go. And it's interesting. I don't think that everybody playing their own games, everybody living in their own worlds, is actually very interesting or maybe even sustainable, because
Or what people want.
it's not really what people want. One of the things that's really important to us is how we share ideas and what kind of culture we build. And how are agents going to bring us together? How are people going to use agents to connect with people maybe that they wouldn't have been able to connect with otherwise, to share ideas, to build new forms of expression and culture? That's a really interesting question for me.
Yeah, I think this goes back to information in a lot of ways. Often maybe we fail to connect because I don't understand what you're saying. We're speaking a slightly different conceptual language. And maybe there's a translation layer. I also think about democracy. There are these larger social institutions that often a lot of us don't feel like we have very much power in, or to change. Large organizations, democracy. And what's interesting about this is democracy is just an algorithm. It's but right now the inputs are binary. You either vote or don't vote.
Yeah.
This is a terrible input to an algorithm. We could actually greatly improve the inputs to this algorithm and get a lot more information out of it. And this is a way in which people can shape the collective that they're a part of much more than they can today, just because today we're not able to take in all of the complex nuance in every person's mind. And so I do see this improved ability to work with information as a way to kind of like help people contribute to the collective and help the collective understand the individuals in it.
Yeah, great. Awesome. Well, we should wrap up. Thank you so much for joining us today. We're going to have a few minutes for questions and answers. If any of you want to go to the microphones, there's one over here and then one over there.
I have one if anybody.
Hi there. Thank you for the talk. I really enjoyed it. Now, I'm an AI engineer, so I have a more technical question and then hoping for a more technical answer. In your example with your AI agents, you're not telling it what to do and it goes to do it like what we have GPT-4 right now. It won't write a program immediately. It'll have a back and forth. What do you want? What are some clarification? So how can you train foundation models to do that as opposed to the immediate, here's exactly what you want right away, this is what you're thinking of?
Yeah, it's a great question. So without getting too much into the details of exactly what we do, there's like a high level, when I'm trying to do a task, if the task is fully specified, like click on this button, then I can do the task. But then sometimes there's ambiguity in the task. For example, figure out like which of my friends are BizOps people so I can reach out to them for user interviews. It's like, okay, well, where should I look to find these friends? What counts as a BizOps person? What we want is models that detect ambiguity. And some of what we do internally is ambiguity detection. That's actually a big part of like helping the user refine exactly what they're trying to do, figuring out like where are there edge cases that are not known about, like not captured in the original spec, and where's their ambiguity in the original ask, and then using that to like get more information from the user. So you can basically the answer is train models to specifically detect ambiguity.
All right, thank you.
Insightful conversation, thank you. I can understand agents working with APIs. There's lots of applications that don't have APIs. How do you think about agents working with that? Is that like bringing in pixels, or are you kind of ready for that world?
Yeah, so a way that we think about it is like a thing that navigates the web is also software. So, if you can write software, you can also navigate the web. That said, I don't think we're going to have to build that part from scratch. I think like the way we think about it is core programming and reasoning. That's like a very hard problem to solve and the most important problem to solve. The other stuff like web navigation or clicking around on a computer, there are going to be SaaS products, many of them. I think a lot of people are working on those. SaaS products that allow you to take some instruction and then figure out where to click. And that's a fairly straightforward like problem to solve, and we'll just use those.
Online. So what are the current?
Okay, thanks.
Oh,
there-
I think your mic's not on, Barbara.
Oh, okay.
Go ahead.
We've got a question from online. Barbara, why don't you just read it out and we'll answer it, and then we'll go to the person at the microphone next.
Yeah, they were asking, what are the barriers preventing AI agents achieving their full potential now?
What are the barriers preventing AI agents from achieving their full potential now? Really, it's everything we talked about. But the biggest, from our perspective, like the biggest things we've seen by building them ourselves is, as a user, I don't trust it to do the things I want. And there are a bunch of reasons why I don't trust it. One is it's not reliable, so it's not actually capable of doing the thing I wanted it to do. Two is it didn't understand what I wanted it to do. So this is why like clarifying ambiguity, surfacing edge cases, et cetera, is really important. The back and forth, the reasoning back and forth is really important. And then three is the interface to agents, a lot of them today, it's like a chat interface. Chat is not a very good interface in a lot of ways. It's very restrictive. It's single-threaded. And so there are much better ways of kind of working with these systems that one day we'll share more about.
I would also add to that, and this is a little controversial, but I feel sometimes as a community we over-index on general intelligence, and sort of there's this idea that like if we achieve general intelligence, then all problems get magically solved. And I feel like that idea in itself is an obstacle for making useful systems, because it's kind of assuming that like the big problems will just solve themselves someday, somehow.
Yeah.
And by the way, I love research towards AGI, so I'm not trying to say that research towards AGI is bad. I just feel like this quest of like, how do we like? I feel like the framing of AGI sometimes creates the gap.
It's totally true. Yeah. Actually, I think it's very confusing what a general intelligence is in a lot of ways. Like humans are a specific intelligence.
Right.
And so general, but general at what? And I think like general, like training on the whole internet still helps us write better code. Well, a filtered version of the whole internet. But it's kind of like the model only has so much like computing processing power in it and like ability to learn representations. And so choosing what data we train it on is really important. And like there's no such thing as like fully general data.
Yeah.
Yeah.
Yeah. Thank you. Next question.
Hi, great talk, by the way. So I have a bit of trouble pinning down the question. Luckily, it seems like I'm the last person.
Oh,
Okay,
so you're giving us an ambiguous question.
Let's see.
Perfect.
Okay, so
I might need an agent to understand it.
well,
Oh,
it's
boy.
kind of towards the point of the question. So within the last years, the last days, sorry, there's been a few talks where the topic of simulated worlds versus AI agents has surfaced. And from a business standpoint, from an industry standpoint, there are a lot of business processes that are complex interactions between users and systems, but they're not very complex. The domain of alternatives is constrained. But today, when I see examples of these simulated worlds, I see Minecraft, and the motivation of the pig is, I don't know, not dying, right? But the motivation of users within these systems is maybe I'm an ignorant user about asking for a purchase order to be emitted, right? But I don't have the information and I need assistance, or I do have the information and I need this fast track, etc. So is there a place where you see these simulated worlds converging towards these more complex AI agents, where you can pre-test them, right? You can see if they work before rolling them out, which is kind of the big stopper for industry.
Yeah.
Huh.
Yeah, absolutely. I mean, that's why we were talking earlier about the omniverse. I mean, I fully believe that a lot of agents need a playground to learn and to test, and I think that looks like the omniverse.
I think it's interesting. I don't know, maybe more pragmatically before we have the omniverse. I think like when we write software, we already test it. We test it by trying out inputs and seeing what happens. And we have like test environments and stuff for it. And so thinking of agents as building software, like we get the testing kind of for free. Like I build, maybe I'll build this process that figures out purchase orders that I want and like puts them somewhere. Then I can test it like I test a normal software program. I don't have to rely on the agent to, like I think there's like a model of agents where you rely on the agent to magically know how to deal with the situation. And that's not realistic for a while. So you don't need simulated worlds, just write software and make a test environment.
There we go. Awesome. Well, we're going to have to stop with questions just because we're running out of time, but we can follow up with a few people offline. But thanks again for coming this morning and being here for this discussion about agents. I'm really excited to see where this goes.
Thanks, Brian.
share a mic.
Yeah, this is the section 2. And then how about for the 11 o'clock section? Can I stay here?
No, you would have to exit. They're going to form a line outside, and then you.
So here will be got key here. Here will be here. I got the one here.
Yes, I want it on. We're going to clear the room.
Oh.
Yeah.
So I should get the mic again.
Thank you all for attending the session. At this time, we are going to ask everyone to exit the room, please. We do need to clear the room. Again, thank you all for attending the session. At this time, everyone must clear the room. Can we please have everyone stand up and head toward the exit? Thank you. I got you. I'm sorry, I was talking, I heard nothing.
I helped with the keynote, but thankfully I wasn't
Okay. If we can please have everyone exit the room. We do need to clear the room for the next session. Thank you so much.
Operational research in college. Yeah.
How do you like make a supply chain work?
Yes. Yeah.
Processes,
Yeah.
And I think like it's very manual traditionally.
Yes.
It's because it's so expensive to run software.
Yeah.
But if it could be very easy for us to run software, then that would help.
There's